Okay, before we get into the next lesson, we're going to look at a summary of graphing quadratics in standard form. As you remember, or I hope you remember, standard form is when a graph is written as ax squared plus bx plus c. Something to keep in mind, and we've seen through some of the word problems, that c value does not need to be there. And also, the b value doesn't need to be there. To be a quadratic, it simply must have at least an x squared term there. And a few reminders. If the a value is positive, the graph points up. And if the a value is negative, just positive. And if the a value is negative, the graph points down. A couple other little reminders. If the a value is bigger than 1, if it equals 1, and less than 1. And what is it we should remember from that? If the a value is equal to 1, we would call that normal width. If it's bigger than 1, it becomes narrower than the normal. And if the a value is less than 1, the graph becomes wider than the normal. Alright, so if we take a look over here, we see that our a value is 2, and it's positive 2, which means that the graph should point up. B is 4, C is equal to -6. So I'll sketch what we have going on here. Where we have an x-axis and a y-axis. Our graph is going to point up. First step then is to find the vertex, which is x, y value, and that's going to be where the bend in the graph is. So if our graph is pointing up, the vertex will be located here. In order to get the vertex, you need to know the axis of symmetry. So what is the line, the vertical line, that will draw straight down through the vertex? We'll cut the graph into equal pieces. So to find that, we use a short formula, negative b over 2a. So the negative stays there. We put in our b value, which is 4. 2 times our a value, which is 2. And we have negative 4 over 4, or negative 1. So on our graph here, okay, that's what we would have. Using the axis of symmetry, the x value, we're going to input that back into our equation. So we have y equals, just get that blinking cursor out of the way, there, so it's not distracting. Okay. So we have 2x squared plus 4x minus 6. Okay, that's our original equation. We're going to substitute this value into our equation. Alright, negative 1 squared is 1. Multiply that by 2. 2. 4 times negative 1 is negative 4. Subtract 6. 2 take away negative 4 is negative 2. Subtract 8 is, subtract 6 is negative 8. So our y value is negative 8. So with a y value of negative 8, that's the y value of our vertex. So we have the x value, which came from our axis of symmetry, and now we have our y value. So if we thought of it this way, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have a graph that we know is going to go up. In order to graph these, we said it was nice to have an extra point there. So what if we said we knew I'm just picking a point arbitrarily here, but let's say if we knew when the x value was 0, what's the y value? So I just need an extra point to graph. And I decided to use an x value of 0. I didn't have to use an x value of 0, I could have said an x value of 1, 2, 3, or -2, -3, -4. Just decided to pick 0. So let's take our original equation. Let's tie that up there. And we're going to put 0 in everywhere we have an x. Nice thing about using 0 is that these values all cancel out. 0 squared is 0, times 2 is 0. 4 times 0 is 0. We're left just with -6. So if I want to plot that extra point, 1, 2, 3, 4, 5, 6. Here. So if I am one space away from the axis of symmetry, I have a height of -6. If I go one space on the other side, say here at -2, I'll have that same height. That would let me complete my graph. And I would look a little bit like that. Some other things we've filled out along the way as we're doing this. The graph has a minimum. That's the lowest point. And that is here at -8. The graph does not go any lower than that. So it has a minimum. And that occurs at y equals -8. And then we've added in our domain and our range. So for x values, the graph is forever moving to the right and it's moving to the left. So for your domain, your x values could be any number, so we just say they belong to a set of all real numbers. For the range, here's the lowest point. The lowest y value is -8. So all other y values have to be bigger than or equal to -8. Now, as the y values get bigger than -8, they could be any number after that. So they belong to the set of real numbers. We get a very general sketch of our graph here. One disadvantage of graphing this way is that we don't have our x-intercepts. The points here on the graph, knowing where along the x-axis the graph will actually break through. We can't tell that. So the x-intercepts at this point right now are a bit of a mystery to us. X-intercepts are also called zeros, and we're going to look at that in the next video. And we'll learn how to find those.